Good morning, everyone. My name is Brett KenCairn. I'm with the City of Boulder Climate Initiatives Department. I'm a Senior Policy Advisor for Climate and Resilience. I'm also the Director of the Urban Drawdown Initiative. Today I'm going to be talking about biochar and bioenergy, and I hope we keep those two terms close together. In the context of city climate action, I'll describe the significant changes that are taking place in climate action that's bringing forth the issue of carbon drawdown and therefore the potential for biochar as a part of that. Talk about some of the work that the Urban Drawdown Initiative is doing with cities around the world around building some of these tools, especially around bioenergy and biochar. Talk about some of the applications, some specific instances that we're working on, and then talk about the next steps that we see in this work from the sort of city's perspective. I think it's first important for those of you who don't spend all of your time, and I hope most of you don't because it's kind of a depressing field, talking about climate and climate action. But it's important to note that there was a real sea change in this field a couple of years ago in 2018 when the IPCC issued its report on the progress being made since the Paris Accords in 2015. And kind of no surprise to most of us that the news wasn't good, but there was a very significant shift in the IPCC's recommendations. One of the things that they had been saying for 20 plus years is that the core to climate stabilization was emissions reduction. And in this report, they said that while that had been their almost exclusive focus leading up to this report, because climate change has progressed so significantly, it's now impossible to stabilize climate without significant withdrawal of carbon from the atmosphere. So this notion of carbon sequestration or carbon drawdown is now integral to being able to stabilize climate. So it opens up this whole new field for many actors in the climate space that they hadn't been doing anything at all in. And then the other thing that they said is that climate change is now advancing to such an extent that there's no way of avoiding significant impacts as we're all seeing, and that we're going to have to start preparing our communities for those impacts. Just to underscore this point and also to kind of bring it into the urban context, this is a report from last summer from the Union of Concerned Scientists. And this one fact, which is just in the executive summary, which is correlated to a variety of different pieces of research that are confirming that basically the trajectories of warming that are now underway and essentially unavoidable will be resulting in very significant impacts in cities. In heat alone, this statistic that something like a third of the 480 largest metropolitan areas, over 50,000 people, are going to be experiencing 30 days or more of temperatures with a heat index over 105 degrees. 30 days or more for over a third of our cities in that kind of a context, when now we have 3 cities that typically experience that. So our cities are not built for this. So it's just to underscore that this is an issue that is rising rapidly and that we're going to have to address quickly. So in the context of this climate stabilization discussion, then, the whole issue of carbon removal has become this massive focus. And one of the pieces of information that's coming along with this is that essentially the only place that we know of to be able to do this carbon sequestration now is in natural climate solutions, in living systems. Now there's lots of technologists out there that are quite excitedly trying to develop all sorts of new sorts of very expensive capital focused technologies. But right now it's the living systems that offer the greatest possibility. And one recent study said that about a third of all the sort of climate stabilization work that we need to do between now and 2030 can be done through working with living systems. So that was underscored by a report that came out last summer, again, around climate change in land, which kind of just made that point that it's now our capacity to live on this planet is dependent now on us mobilizing at a global scale to implement living system regeneration. So In terms of where the opportunities in living systems are, this is another analysis that is taken from the IPCC work, or that they drew from studies around. And you can see that, as one would expect, forestry is very high in this area, especially both keeping forests in their natural states and also reforestation. But urban forests are actually a much bigger factor than many might have thought. And I think that even this number that's highlighted here, something in the order of, um, close to 50 million tons of carbon annually, is probably a significant understatement if we start to implement some of the ideas that we're going to talk about here in a few minutes. Another aspect of this, though, and I think this is very, very important in terms of how we think about the problem, the current or past, I would say, paradigm of climate action is that carbon is a problem and we simply need to get it out of the atmosphere or stop putting it in there, and then everything will be fine. When in fact, of course, carbon is one of the most essential elements to all life. It has an intimate relationship with water, so that the more carbon we can put in the soil, of course, the more it holds water. It is a part of being able to create shade. It's all of these things. So especially in the urban work, I think it's started to emphasize that it's not just about how many tons of carbon we can take out of the atmosphere and then put somewhere. It's about how many tons of carbon we can take out of the atmosphere and put back into living systems in ways that are strategic and that help us achieve a whole bunch of other objectives, like rapidly growing shade, or increasing the amount of stormwater infiltration we can hold in our cities, or creating nutrient-dense food, or detoxifying all these different places that we have toxins. These are all benefits that can come from strategically managing carbon. So rather than carbon removal being our focus, I would say our focus now is carbon management. And this is just, a simple way of illustrating that when we think about these ecosystems that essentially, and I think it's an under-recognized truth about climate change, is that much of the carbon that's in the atmosphere actually originated in current carbon in living systems that have been decarbonized. And we see this in the city of Boulder's open space lands, which we prize very highly, but because of our past management, we have participated in or just extended this legacy that started since we started overgrazing the lands over 100 years ago, of decarbonizing these landscapes in ways that they are no longer able to do many of the functions like water infiltration and holding and things that they could have done. So this is just to say that there's all these different things that we can accomplish if we manage carbon into living systems in ways that create ecosystem services that we want. Carbon is almost like the co-benefit, especially in the context of needing much more climate resilience. It may be that we will value these other ecosystem services even more than the carbon. But it does raise an interesting point, by the way, that in thinking about how we value the carbon that we're drawing out of the atmosphere and putting into these systems, I would argue that a ton of carbon sequestered into an urban living system in ways that's going to accelerate the development of shade, or increase the amount of stormwater that we can retain in those systems, or create more nutrient-dense food, or detoxify areas, that ton of carbon should be worth 10 to 100 times more than a ton of carbon sequestered in a poplar plantation in the middle of somewhere, because we're accomplishing much more with it. So this is a part of the premise that the Urban Drawdown Initiative was created around, is that we want to kickstart the capacity of cities locally, regionally, nationally, internationally, to disseminate these carbon drawdown and management capabilities. And this is very important, though, in ways that the economic opportunities that creates are directed towards and with the communities that have been underserved and under-resourced historically. And I'll show you some of the examples of that. So I should note that the Urban Drawdown Initiative is a sponsored project of the Urban Sustainability Directors Network, this fantastic collection of over 214 cities around North America that are working together on many different sustainability related things, and works closely with the Carbon Neutral Cities Alliance that works with cities all over the world who are on the leading edge of climate action. More locally, this is some of the work that we've been doing in Boulder. We started our carbon drawdown journey working on our agricultural lands. This is a very degraded site that we have that had basically lost almost all, in fact, lost all of its topsoil and much of its A horizon. And that through a combination of treatments that we've been trying out, which includes compost and biochar, and especially keyline plowing, we've been able to start to bring that site back. And I'll show you more about that in a few minutes. In the context internationally, we've been working with cities like Stockholm, who've been exploring the use of biochar in their urban tree plantings in what are called structured soils. They're creating that biochar in a system that is hooked to a district heating network. So it's one of these elegant examples of capturing the energy value of the pyrolysis process and putting that into an application which displaces a fossil fuel, natural gas, or I should say fossil gas, which is one of the most difficult renewable energy transitions, by the way, and then is turning that byproduct or that co-product, biochar, into something that is not only helping sequester more carbon, because their statistics show that it's more rapidly growing their trees and helping them survive more, but it's also significantly contributing to their climate resilience, like shade and water infiltration and so on. This is a shot of that plant in Stockholm. This is a sort of 1/20th scale version, by the way. They're now in the midst of significantly expanding this site. This is just a schematic of what they call their structured soil approach. It is very labor and capital intensive to get this established, but this now becomes not only a sort of tree host, but it's actually a stormwater infiltration system and a detoxification system all in one. And like I said, they've had very impressive results of increasing their growth rates by about 25%, decreasing their mortality rates by up to 50%, and then therefore achieving these other objectives. This is just a shot in Stockholm of them actually installing one of these sites. This is a finished site, again, showing how they're starting to create these stormwater retention basins in this way. In Minneapolis, they've done very similar work. In fact, that's Jim Doughton with examples of corn that they grew with biochar and without. You can see the one on the right is the one that was grown with biochar. They've had remarkable results both in their urban tree planting, but also in urban agriculture. They're also using biochar in toxic remediation. So very encouraging results there. And Jim has been a part of the biochar working group that we're developing with the Carbon Neutral Cities Alliance. We're also doing work, as I mentioned, this sort of equity-based development approach, working with groups, frontline kind of urban ag and community food security folks like the Rid-All Green Partnership in Cleveland, the Detroit Black Food Community Network in Detroit, Covenant Pathways, which is out on the Navajo Nation, and then a rural farm cooperative in southern New Mexico. Those groups are using a really exciting decentralized modular biochar bioenergy technology that will be heating their greenhouses so they can achieve 4-season growing, creating biochar, which is a co-product for them, using then mixing in their compost, and then being able to start to scale that up to be able to provide tree planting amendments for the large-scale urban tree planting efforts that we're working on launching nationally. So interesting work there. This is actually a schematic, or just a sort of visual of the key elements of this system that I mentioned. It's being produced by a company called Trollworks out of Silver City, just to kind of give you a sense of what the core components of this are. This really builds on critical knowledge that was gained in the hard way from the biomass energy era, where we learned that it's not just the conversion technology that's important, but it's really important how you think about handling your feedstocks. And so one of the things that this system does is use relatively low-cost feedstock preparation systems that then take a wood chip or a pecan shell or any other type of biomass waste and densify it, in this case turning it into a low-density industrial-grade pellet. And it's that pellet that becomes the material that's used in the pyrolyzer. And because they've developed a continuous feed pyrolysis system, that it actually enables that, of course, that system to operate much more efficiently because you have that uniform feedstock material. So all of this then, these wouldn't necessarily all be co-located in one entity like this, but just kind of showing the key elements of their kind of innovation and technology. And then what that starts to enable in an urban context is that we can take these sources of urban biomass waste. I mean, in Boulder, for example, we're currently shipping out somewhere between 1,500 to 2,000 tons of woody biomass a year, just because there's no well-established use, no economic use for that. We're shipping it out of the community to composters, when in fact we could be turning that into energy and biochar. And so that's a part of the vision of this, is once we have these kind of pyrolysis units that are continuous feed that we can marry to a heat need, whether that's a brewery or a greenhouse or a large public open space, we can be displacing that fossil gas use, which again is a very important objective in our emissions reduction side, producing biochar as a co-product to that, and then taking that biochar and getting it into our agricultural or other contexts where we're using it to actually sequester even more carbon. So it's a kind of beautiful circular economy around this kind of element. Now, I think this is really a moment that I want to then sort of illustrate the difference between this kind of a technology configuration and approach and others, which isn't necessarily to totally dismiss the others, but in many of these other approaches, which are large centralized facilities set up just to produce biochar, often using batching systems, they're basically blowing off, something like 40 or 50% of the energy value of that material into the atmosphere, because the only product you're after is that biochar. And that then doesn't give you the capability of doing this kind of displacement of fossil gas and all these different other uses, as well as this kind of distribution of the benefits and the opportunities that this bioenergy plus biochar can kind of create. So I'm really intrigued by this more modular, decentralized, distributed biochar or bioenergy system, as opposed to that kind of centralized approach. So in terms of next steps, and to finish up here, through the work we're doing with the Carbon Neutral Cities Alliance, we're about to conduct a urban biochar opportunity assessment, in which we'll be looking at kind of framing up what the opportunities are for urban communities using these systems. And that will be the kind of foundation with which the CNCA group will actually build out a whole new kind of game changer practice area to help support cities in that work. We're also working on these tools. As I've mentioned, we're working with Trust for Public Land to develop spatial analysis tools with which cities can start to assess where their carbon drawdown opportunities are in terms of which living systems they can prioritize, how to prioritize those to get carbon back into those systems to achieve the ecosystem benefits that they provide, whether that's shade, stormwater infiltration, or what have you. But then how do they locate those spatially? How do they coordinate those with other activities? Those are the tools that we're building there. I mentioned that. This is an example of that tool that we're working on. This is a shot from Cleveland, where the base frame of this tool has been built. This is actually looking at heat island dynamics. So this would help us to start figuring out where to target more urban forest development. But it also might help us to think about where we want to be managing our urban forests actively, and even be starting to calculate the biomass that might produce. There's a lot of research that we need to be doing. This is a group that we've been starting to talk to, is the Natural Resource Research Institute up in University of Minnesota Duluth. They've been developing a whole biochar sort of practice area and acumen. And this is really important because I mentioned Jim Doughton in Minneapolis. One of the cool things that they did was they went to Stockholm to see what Stockholm was up to. He took his public works director from Minneapolis there. The public works director got really excited, came back and started to say, all of our tree plantings are going to start using structured soil, which is all fantastic, except that the public works director has no way to specify biochar. We don't have enough information yet to really be able to build that into our procurement guidelines. And finally, to start doing these kind of pilot installations, we'll be putting in one of these systems at a greenhouse late this fall, early this winter, and then be putting 4 more of these in that are producing heat biochar. We're also going to be conducting an urban biomass assessment and try to create a template for that kind of assessment of what the woody biomass capabilities are in these urban centers. And we're working on that with American Forest, Davey Tree, and the Forest Service. So I'll just close by saying, it's a very difficult time. There's a lot of challenges. This is my son standing on that property that I mentioned we've been working on. This is before we even got started. This is about a year later after less than a year later after we'd started that work. It just goes to show you there's a lot of resilience capabilities in these systems, and it's time for us to harness those. So thank you very much. This is my contact information. I look forward to participating during the breakouts and wish all of you the best of luck in your work. Thank you.